In this lecture, we are going to learn about the ellipsis catch-all block. And this is a catch block that can catch and handle any kind of thrown exception. Let's look at a simple example. Here we have a simple function which is going to throw all kinds of exceptions. If I is 0, we are going to throw an integer. We can throw a const char pointer. We can throw a critical error. This is our own class object. And we can throw an std string. Once we have this function, we can set up a piece of code like this, which is going to be looping 5 times. And inside we have a bunch of nested try blocks. So the first one is here, and we are going to loop inside. And we are going to be calling our functions on these indexes here. Inside we have a bunch of catch blocks. The first one is going to catch an integer, but the second one is an ellipsis catch-all block. Notice that we have 3 dots inside. This is the syntax we use to say that this is a catch block that can really catch any kind of exception in our try block. And anything that is not handled by this integer is going to be caught by this catch block here. If you want, you can handle anything in this try block, but note that it is also possible to rethrow this exception to be handled by englobing scopes. If we do rethrow this exception, it is going to be caught by the outer try block, and its matching catch block is going to be activated. We're going to see that we are going to be catching strings here, which are not handled internally in our inner try block, but anything else is going to be sent to the second ellipsis catch block here, which is really going to handle any kind of exception you throw at it. This is the setup we can do to make these things work. One thing you should know is that the ellipsis catch-all block should be the last catch block in your series of catch blocks. Because if it is first, it is really going to catch anything, and any catch block after it is not going to get a chance to run. For this reason, even compilers are going to enforce for you to put it last. So if you try to put a catch block after that, you're going to get a compiler error. This is really good. It is by design. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is ellipsis catch-all block. We are going to grab our template files, but this time we are going to be reusing the code from polymorphic exceptions here because we need the exception class that we have in our exceptions.h header. So let's grab everything here. This is going to be our starting point, and we are going to put our code in our current project. Let's open this up in Visual Studio Code by dragging and dropping here, and we will have our exception class. This is going to be a polymorphic inheritance hierarchy, which is going to give us a warning class, a small error class, and a critical error class that we can use in the main function. So let's go there and try to do this. We are going to remove our function here, and we are going to replace this with another function. And we can remove our for loop that we have in our main function because we are going to put in another one. Let's put in the exact function we had in the slides. So we are going to be able to throw all kinds of crazy exceptions. We can throw an integer like we do here. We can throw a const char pointer. We can throw a critical error, or we can throw an std string. This is going to work, but we don't have a default constructor for this guy. So let's see if we remove this. And we have a squiggly line here. Let's see why. Let's try to build this and see if the compiler is going to take our code here. And we are going to have an error, and we are going to see that no candidate critical error. Let's go back in our class and see what we have as a constructor for critical error. And this is going to take a string n, so we need to pass this in. Let's do that, and we are going to say something is wrong. We can do something like this. And this is going to do whatever it is we want to do here. We can build and see if the error goes away. Let's pass this through GCC, and the build is good. We are all good here. Now, in the main function, we are going to set up a bunch of try blocks. We are going to put an outer try block, which is going to wrap around our for loop. And inside we're going to loop 5 times from 0 to 4, and we are going to be calling our function inside a try block. And this is going to throw exceptions that are going to be handled first hand by the catch blocks that we have attached to this try block. So we are handling integers. So the integer exception is going to be handled at this point here, but any other kind of exception is going to be sent to the ellipsis catch-all block that we have here. So anything we want to handle in here, we can handle that, but we can also rethrow the exceptions to be handled by outer try blocks. So if we rethrow an exception like this, it is going to be handled by this try block, and its attached catch blocks are going to handle that, and we're going to see this here. Let's try and run this program and see how it is going to behave. We can pass this through GCC. The build is going to be good, so we can bring up a PowerShell window pretty fast. Let's do that. And we are going to clear and run Rooster. We are going to see that for the first iteration, we are going to throw an integer here, which is going to be caught by the inner catch block. That's what we see here. For the second iteration, we are going to throw a const car pointer, which is going to be not handled by the catch block here. It is going to be rethrown and handled by the outer try block here. And when this guy is rethrown, notice that we are going to go out of this loop here. So the loop is going to stop executing, and we are going to fall out of the inner try block here. We are going to hit the outside catch handlers here, and we are going to handle the string and say that we caught some string exception. That's what we see here. Notice that once we rethrow this exception, we are going to fall out of the inner try block here, and we are going to come to the outer scope. This is going to stop execution of this loop, and we are going to come to this catch handlers here. What we have just thrown is a const car pointer type, so it is not going to be a string. It is going to be caught by the outer ellipsis catch all block, and we are going to say this message here, outer handler caught some other exception, and our program is going to end. Notice that exceptions can really change the flow of your program, and that's why some people find them confusing and avoid them altogether. But I am going to leave this choice to you. What we are learning about here is the ellipsis catch all block. And hopefully this shows you that you can really use it to catch any kind of exception in your C++ program. My piece of advice is that you should really avoid using this too much, because it is going to make it really hard to know which kind of problem you have in your program. You see that we have no way to know which kind of exception actually happened. All we know is that something went wrong and we can prevent our program from crashing, but we don't really know what went wrong, and this is bad. You should avoid this kind of thing in your design. But again, this is my opinion. You are free to use whatever makes sense for whatever you are designing with your C++ program. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about the no except specifier, something you can set up to prevent exceptions from going out a given function. Go ahead and finish up here and meet me there.